Hello. In the last class, we discussed one of the classifications of signals, that is periodic and non-periodic signals. And in this class, we will continue discussions on classification of signals. So we discuss two different classifications. One is deterministic and random signals, and the second one is energy and power signals. The next classification of signals is deterministic and random signals. So, as the name itself says, the meaning of a deterministic signal means so if there is no uncertainty with respect to the time, there is no uncertainty of the value of the signal with respect to time, then we call such a signal as deterministic signal. For example, say x of t is a sine omega naught t. So as you can see, at all the time t, there is certain that the magnitude of the signal is calculated by using this equation. Means all the values are certain. So which means there is no uncertainty with respect to the signal. And these deterministic signals can be modeled as functions of time. Then what is a random signal? Again, as the name itself says, there is uncertainty before actually the signal occurs. So there is uncertainty of the value of the signal before it occurs. So a good example for a random signal is the noise signal that is going to corrupt the data when the signal is being transferred. So this is one of the classifications, and a noise signal, you cannot model by using any function of time, and you have to use a probabilistic approach to deal with this signal. So the last classification is energy and power signal. So signals can be classified as energy or power signal. Okay, let us first now try to understand the meaning of these terms energy and power. Let me just consider a resistor whose values are, and a signal that is applied, an voltage signal applied is V of t, leading to a current signal I of t. So we know that power is given by voltage square divided by the resistance, or current square multiplied by the resistance. So if I assume R is equal to say 1 ohm, then you can observe that power of the signal can be written as square of the instantaneous value of the voltage or the current signal, which in general can be written as say x square of t. Now the total energy of the signal given by E is calculated by using the equation under limiting case integration from minus t by 2 to plus t by 2 square of the instantaneous value of the signal as time t tends to infinity. So we can write energy E to be minus infinity to infinity x square t dt. So energy of a signal can be calculated by using this equation. And power of the signal P can be defined as you know, it is the average energy over one period. So minus t by 2 to plus t by 2 x square of t dt averaged over one period. And for a periodic signal, over P can be calculated by using 1 by t minus t by 2 to plus t by 2 x square of t dt. So this is how I can determine power of a periodic signal. Similarly, for a discrete signal, I can calculate the energy using the equation summation n going from minus infinity to infinity x square of n, and power can be calculated as under limiting case 1 by 2n summation n is equal to minus n to plus n x square of n. And for periodic signal, power can be calculated by the equation 1 by n summation n is equal to 0 to n minus 1 x square of n. So we have understood how we can define energy of a given signal and power of a signal. Now let us define what is an energy signal. So if the energy of the signal is finite, that means if the energy E calculated by the formula discussed now, if energy is finite, then we call such a signal as energy signal. Similarly, if power is finite, then we call such a signal as power signal. So in fact, there is a mutually exclusive condition here. What we mean is an energy signal will have zero power. A power signal will have infinite energy. So this is a mutually exclusive principle. An energy signal will have zero power and a power signal will have infinite energy. Now, what are the examples? Deterministic signals, which are non-periodic signals, are examples for energy signal. And periodic signals, noise signal is example for power signal. So this is how we can classify signals into energy signals and power signals. Let us just solve a simple problem on this. So we will just take an example. So it's a rectangular pulse defined over T1. The width is T1 and the magnitude is A. This is the signal X of T. And I can calculate the energy of this signal. This is a non-periodic signal, so let us calculate the energy. So energy, as you know, you can, okay, as by definition, it is from minus infinity to infinity, x square of t dt. And here the signal exists only over a period minus t1 by 2 to plus t1 by 2. And the value is a, so a square dt. This is a square t minus t1 by 2 to plus t1 by 2. So you can observe that energy of this signal is a square t1 by 2 minus of minus t1 by 2 is t1. So this is energy of the signal. And as you can see, this value is finite. So the given signal is an energy signal. So this is how we can verify a given signal is an energy signal or power signal. Similarly, let us take an example for a power signal. So let's take a periodic signal. So this is x of t, and the value is plus 1, minus 1. This is 0, and this value is 0.2, which means this value is 0.1. It's a periodic signal, as you can see. So let us try to estimate the power of this signal. Period is 0.2, so it is 1 by 0.2. Integration 0 to 0.11 square dt plus integral from 0.1 to 0.2 1 square minus 1 square dt, because from 0.1 to 0.2 the value is minus 1. So if you simplify this, you will get the value as 1. So, and you can observe that this is finite. Hence, this is an example for power signal. So, like this, you can verify uh, whether a given signal is energy signal or power signal. So, you have to determine the value of energy or the power of the signal. If energy is finite, it is an energy signal. If power is finite, it is a power signal. So this is the last classification of signal into energy or power signal. So in the next class, let us try to perform some operations on signals. So we will continue in the next class with some operations on signals.